Hello, 7th graders. This video is going to be about finding the midpoint of a line segment in a plane. And I always teach this topic at the same time, same day, as the distance formula. Because it just seems to me that if you have 2 points in the plane, there are 2 natural questions to ask. Make a line segment out of the 2 points. How long is it? And the same line segment between those same 2 points, what are the coordinates of the midpoint? In geometry, it's always sort of an interesting question to ask those 2 questions, length and also any line segment has a midpoint. So let's first review what we learned about the distance between 2 points. And again, I'll emphasize to you that going forward into high school math, you'll see this occasionally, a way of representing 2 arbitrary points in the coordinate plane. We can think of this as point 1 and call its coordinates x sub 1 and y sub 1. Think of this as point 2, x sub 2, y sub 2. The distance between those 2 points, represented by this d here, is the square root of the difference of the x's squared plus the difference of the y's squared. And I wrote underneath it the solution to the Pythagorean theorem, finding the hypotenuse of a right triangle. The c, or hypotenuse of a right triangle, would be the square root of a squared plus b squared. Now this a here, let's think of that. Let's think of the a that's here as the horizontal leg of the right triangle. Well, its length is going to be x2 minus x1, or perhaps, depending on the order that you do it in, it could be the opposite or the negative of the distance of the length of A. But even if you do x2 minus x1 and get a negative number, it doesn't matter because you're going to square that, and when you square a negative, you get a positive. And the B that's here, we can think of that as the vertical leg of the right triangle, and the length of that vertical leg would be y minus y. The y coordinate of the point minus the y coordinate of the other point will give you either the length or the opposite of the length of that vertical leg. And again, when you square it, even if it's the negative, it's going to square to the same thing as the positive, as the true length, which is positive. So the distance formula is nothing more than an application of the Pythagorean theorem. And the midpoint formula is very simple. The coordinates of the midpoint of a line segment are the x coordinate is the average of the 2 x coordinates, and the y coordinate of the midpoint is the average of the 2 y coordinates of the 2 points. The m here, of course, standing for midpoint. So these are the 2 very well-known, very classic formulas for the distance between 2 points and the coordinates of the midpoint of the line segment between those 2 points. And we'll look at a few examples of the midpoint formula. Just like with the distance question, we'll consider 2 special cases of the horizontal line segment and the vertical line segment. This horizontal line segment here has endpoints of 2, 3, and 5, 3. Now, we can get a sense of where the midpoint is going to be, somewhere around here. But the formula tells us how to find the exact coordinates of the midpoint, and that is to take the average of the x's and the average of the y's. So what we'll do here is I'll put the midpoint at a place that I think is pretty good representation of it without measuring. The coordinates of that midpoint are going to be 2 plus 5 over 2 and 3 plus 3 over 2. Add the 2x coordinates and divide by 2. Take the average of the 2x coordinates. That's intuitive. The average is going to be halfway between the 2 and the 5, which is, of course, 3.5. 7 over 2, 3.5. I won't simplify these because I'm kind of out of space here, but the x coordinate is 3.5. Now the y coordinate was obvious. this was a horizontal line segment, so the y-coordinate had to also be 3. And you get that by taking the average of the two 3's. 3 plus 3 is 6, divided by 2 is 3. So the coordinates of that midpoint are 3.5, 3. Very simple formula based on average. For this vertical line segment, the x-coordinates are the same, -4. That's why it's vertical, by the way. Back here, when we had the horizontal line, the two y-coordinates were the same. In fact, that horizontal line segment that we just looked at is part of the line described by that equation y equals 3, because every point on that horizontal line has a y-coordinate of 3. And in a similar way, every point on this vertical line, this line segment is part of a vertical line, and every point on the vertical line has an x-coordinate of -4. This vertical line is x equals -4. Now, obviously, the x-coordinate of the midpoint is also going to be -4. We'll go through the formula, however. The midpoint, I'll put it in roughly where it looks like it's going to be, somewhere around there. And what are its coordinates? Well, the x-coordinate will be -4, but we'll use the formula and write -4 plus -4 over 2, taking the average of the two x-coordinates, which are both -4. -4 plus -4 divided by 2 is -4. I'll write that down here this time, because I got the space. And now the y-coordinates are -6 and 2. So we take their average. We add -6 and 2 and divide by 2. -6 plus 2 is -4, divided by 2 is -2. So the coordinates, I'll fudge and make the point a little bit bigger so it looks right. The coordinates of that midpoint are -4, -2. So here are a couple of simple cases, special cases, but we use the formula of based on the averages. We'll just find the midpoint now of one diagonal line. I think that should be enough. It's a very simple thing. You could try a few others yourself, maybe on graph paper, and then make sure that the result you get looks correct in terms of where you would put that midpoint. I've chosen the 2 points 4, -1, and -5, -3, and I've reminded us of the formula. The coordinates of the midpoint of this line segment, the coordinates are the average of the two x-coordinates and the average of the two y-coordinates. It's kind of like, I like to think of this situation as kind of like the horizontal and vertical lines on, say, a periscope or a gun sight, which kind of gets you to the point that you want to be looking at in the middle, left to right, and then in the middle, up and down, kind of like what the x and y axes look like, and you're right there in the at the origin with them. But you kind of imagine sort of a tilted x and y coordinate axes, and put a perpendicular bisector, put a line that's perpendicular to this green one, and then where and cutting it in half. Where would they intersect with the x and y axes? That's at the origin, and where would those two sort of scope lines intersect with that? So left to right, the x coordinate will be the average of -5 and 4. So let's just set up our midpoint like this: -5 plus 4 divided by 2. The average, left to right, our midpoint has to be halfway between -5 and 4. And up and down, it has to be halfway between -3 and -1. So we'll find those two averages. The average of the two x's and the average of the two y's. -5 plus 4 over 2 is -1 over 2, -1/2. And the other one, -3 plus -1 divided by 2, -4, divided by 2 is negative 2. So let's see if that point makes sense, if it corresponds with what our eyes tell us. The formula tells us the midpoint of this green line segment is at negative 1/2, negative 2. Well, negative 1/2 over 1 to the left and down 2. Negative 1/2, negative 2 is right there. Actually, when I first drew this line, I thought, is the midpoint on the y-axis? Well, not quite. It's a little bit, the midpoint is a little bit to the left of the y-axis, and it's at negative 1/2, negative 2. So there you go. Very easy to find the midpoint of any line segment in the plane. So long for now.